top. All right. You guys ever seen Community, that show? All about community college. You know it's back now. It's on Yahoo something or other. I watch it in other ways, but it's on Yahoo, whatever they got, some kind of weird service they used to have. And it's as good as always. It's good. If you don't like the show, then screw you. Sorry, I think I'm alright now. So there's two main ways, and I don't know how many of you guys actually looked at this handout, but there's two main ways to look at this. So I give you method one. Method one is the way that I personally do it. And to me, it's better to do it that way. It's a little more direct. Method two works just as fine, though. It kind of makes you do it all the way out. Method one says, and we talked about this a little bit last time, if I have the square root of 28, I don't know what the hell the square root of 28 is. Right? But I can break it apart into a number I can do the square root of, and then something else. So then I say, square root of 4 times 7 is the square root of 4 times the square root of 7. I can pull them back apart, right? Because when can I multiply two radicals? When they are apart. When they're not radicals.
No, when one of them is like...
They must have the same...
Square or...
Little number, dude. They must have the same root. They have to be both cube roots or both square roots. Okay, I don't appreciate that. Let's see. So if I add the cube root of 7 times the cube root of 2, that would be
Cube root of 14.
Cube root of 14. You would hope to God it is, and thankfully it is. See, math says, all right, sure, this one time, I'll let it be what you think it is. Right? But if I had the cube root of 7 times the square root of 2,
that's it.
You can't do shit. You just circle that and say next. Right? So in a way, it's kind of nice. When you're done. Right? So you can only combine them. You can only multiply, or for that matter, divide them if they have the same root. Now we did see one thing last time, and we did this last time, where I had like the square root of x times the cube root of x. Officially, you can't do that, right? But does anybody remember what I did to get around that? Right? I say math, you got rules. It's nice for you, math. But there is a way around the rules here, sort of. How can I rewrite those? What's the square root of x also known as? X to the 1/2. It's sort of like the opposite of x squared, right? So square root of x is x to the 1/2. And what's the cube root of x? 1/3. Why does it make sense? Because a cube root breaks it down in thirds, right? That's what a cube root does. And a square root breaks it in half. So that's why it makes sense that those are the powers on that sucker. They're fractional powers. Telling you that's how much you break it down by. And then what can I do? What has to happen here?
Same denominator.
Why? Why do I need the same denominator? Because I want to combine them by adding. There you go. All right, cool. So if I want to do, because when I multiply like bases, I add the powers. Thank God you don't have to learn any new rules. It's the same old rules of exponents, right? The rules don't care what's up there. The rules say whatever the hell exponents you got, you add them when you multiply like bases. So it'll be 1/2 plus 1/3. Yeah, x to the 3/6 plus 2/6. X to the 5/6. I like it. So you can only multiply when they have the same root. What would be the roots on them at this point, though? What would the roots be?
6.
It's 6 roots. They're both 6 roots. So by making LCDs, I am making the roots the same, kind of in the background. So that rule I can never go. Math goes, you think you got around my rule, but you didn't. I just found a way to make the roots the same on this particular problem. It won't work up here. Why wouldn't that same thing work up here? What are the bases here? X and X. What are the bases here?
7.
Are they the same?
No.
So that whole process would not save this guy. Nothing's the same up here. Screw that. I can't save it. Or how do we know?
Why can't you do it on the other one?
Because the bases are the same.
So if instead of a 2, if it was a 7?
Let's try.
49.
Let's try. Wait. You gotta be careful. Can you make that something 49?
No, because then it goes back to 7.
Well, even more importantly, can you just multiply those? Why not?
Because they don't have the same.
They don't have the same root, right? You can only multiply them if they have the same root. In fact, we've been doing that forever. What's 2 times 5? 10. Why were you allowed to do that? Because they both don't have a root. So they have the same root, not 1. Right?
But you can't break down like you did.
Totally. You ready?
Oh, yeah.
All right. How do I rewrite cube root of 7? 7 to the
1/3.
1/3. How do I rewrite square root of 7? 7 to the 1/2. Cool. And then I can do the same thing we did earlier.
So 7 to the 5.
Now be careful. The wrong thing to write, and I appreciate what you just said. You said it correctly. The wrong thing to write would be 49 anything. No. I don't have any freaking 49s. I have 7 to the 1/3 plus 1/2. And we already did all that work, right? So it'd be 7 to the 5/6. And of course, why does that make sense? What is x? Anything you want to be. So if it was 7, the answer should be 7 to the 5/6. And what did we get when we made it 7? We got 7 to the 5/6. Of course we did, because we've proved over here. Whatever the hell you make x, this is going to be the answer. All right, how are we doing? As long as the base is the same. If the roots are the same, I don't care. You can put them together. Just slap them together. If the roots aren't the same, then if the bases are the same, you have a way around it. Well, if they aren't the same, that's because I can't help you.
If the roots were the same, instead of a 7, would it change to a 49?
Yeah, just like this one. You see, the roots were the same, so I made that 14. So if that was a 7, if it was the cube root of 7 times the cube root of 7, that is the cube root of
14.
No.
I mean, 49.
Times.
I was looking at
49. It's times, right? That's it. Why can't I take the cube root of 49? How many things does it have in it?
3.
We know where it came from. Where did it come from? How many 7s?
2 7s.
49 has 2 7s, but a cube root needs 3 things in it. So I can't do the cube root of 49. I can't break it down. It doesn't have enough stuff. Or maybe. All right. So, back up here. Square root of 28 kind of sucks. But what I'm trying to do is trying to take it, maybe start here and go backwards and see if it'll go anywhere. Break it up into parts. So I could break up the square root of 28 as square root of 14 times square root of 2. Why is that silly? Is either one of those better? No. So I'd much rather break it up as square root of 4 times square root of 7 because square root of 4 is 2. What's the square root of 7? I don't know. So then you leave it. How we doing? So see, the idea is you break the number up into a part you can do times a part you can't. And then, not surprisingly, you do the part you can do and you leave the part you can't do. I really want to, now let's see if you guys get this analogy, because I love this analogy, right? What could I do with 11 over 8? Does 8 go into 11?
No.
No. The same way that the square root of 28, square root doesn't go into 28. Those don't go together, right? But look what I can do with 11/8. I can break it up into a part that I can do plus a part that I can't do. I do the part I can do, and I leave the part I can't do, so this is 1 3/8. It's the same damn thing, right? Division by 8. What's the only kind of numbers I can divide by 8? 8, 16, 24, multiples of 8. So then I break the number I have up into one of those plus extra. So what do I do with 28? I break it up into a number the square root likes times extra. Does that make sense? Yes. It's a beautiful analogy. I'm hoping. All right, and some of you guys are like, yeah, stop talking about it. And so forth. You can see the other examples I give you. Right. Method 2 is just take the number and just break it all the way down. And the square root is looking for how many things? 2. So anytime you see 2 of anything, you take one of them out. The square root needs 2 things. When I see 2 things, I put one of them on here. The cube root needs 3 things. When I see 3 things, I put one outside.
Then you multiply together, right?
Yep, so that's 2 root 7. That's the same answer we got up there. The next one, I break 54 all the way down. 3 times 3 times 3 times 2. I see 2 3s. So I put a 3 out, and what's left inside is 3 times 2, which is 6, which is the same answer I got up there. Coolness. How are we doing? So one of those methods you have to pick. All right. If there's a third method, let me know, because I don't know about it. And the third method is not calculator. Because if you put this in your calculator, it's going to give you 7.0 whatever. That's no good. I don't want that shit. How do I break 50 up?
29 times 2.
Yeah, I can break it up into 25 times 2. They're both square roots still because I can't get rid of the root. Square root of 50 is square root of 25 times square root of 2. What is the square root of 25? 5. What's the square root of 2? I don't know. Yeah, good. I get a lot of people that give me this as an answer. And I'm like, how does the 5 stay inside? How does the 2 get out? Do you see what I'm saying? So that's somebody that doesn't really fully understand. They just know they get those numbers and they don't know where they go. And that's not the point. It's not where does the numbers go. It's break the 50 up and then actually take the square root of one of them. The square root of 25 is 5. Why would it still be in the square root?
62?
Yeah, and watch this. I'm going to purposefully do this not quite right, just to show you what happens if you don't. It's just like reducing a fraction. You could reduce several steps. So if I saw that this was 9 times 8, are one of those square rootable? Yeah. So I can say that's the square root of 9 times the square root of 8. What's the square root of 9? 3. What's the square root of 8? I don't know. But what's 8 got in it?
2.
Yeah, so it's got 3 square root of 4 square root of 2. What's the square root of 4? 2. So it's 3 times 2. Alright, so whatever's already outside, it just multiplies. Because what is the operation between the 3 and the square root of 8? Multiplication. So whatever else comes out, I just multiply by it. Now if I would have done what Arby said, Arby's pretty smart with these things. I should have done what he said. 72 is 36 times 2. What's the square root of 36? 6. What's the square root of 2? I don't know, and I'm there. Right? But it's just like simplifying fractions. If you don't happen to see the best way to break it up, just see a way to break it up. Because then what's left over is a smaller number that's easier to do. So just like reducing fractions, you've got to take it, it's got to make sure you're done. All right? How are we doing so far? All right, you guys try the next 3 there. If you've already tried them, just hang out. Don't go crazy, but if I ask you to factor 16, you would say 2 times a, and you go from there. If I said factor 17, you'd go, I'm done. So, one of those you can't really do anything with. Alright, so let me catch up to you guys. How do you break up 120?
10 times 2. 10 times 2.
Yeah, you could do 10 times 12, but then I guess you kept breaking it up.
Yeah.
So if I do method 2, you see I already default to method 1 always. But if you like method 2 better, which is where you just break it all the way down, let's try that out here. So this will be, if I break 120, it's 12 times 10. If I keep going, This will be 3 times 4 times 2 times 5. So I get 3 times 2 times 2 times 2 times 5. Is that cool? What do I see 2 of?
2.
2. So for those 2 2's, 1 2 comes out. And what's left inside? 6 times 5. 30. Is that what you guys got if you did it the other way? Yeah, because the other way would be take 120 and break it up as... How do you do it the other way?
60 and 2. Did we only do
Who?
60 times 2?
60 times.
But to do it the other way, I want a number I can take the square root of times something else. And what goes into 120 that I can take the square root of? What numbers can I take the square root of? 1. What else? What else can I take the square root of nicely? 4, 9, 60. All your squares. So you just start dividing by those until you get one that works. And of course, 4 goes into 120. So 120 is 4 times 30. What's the square root of 4? 2. What's the square root of 30? I don't know. So you get the same answer either way I do it. Thank God. And why do I stop at 30? Because 30 is made up of a 3, a 2, and a 5. There ain't 2 and nothing in him, so I can't do anything with him. Guys are like, really? Spring break, man. That's too damn bad. Just because you were doing that, I'm going to make us stay a few more minutes. What about this one?
4 times 4.
Yeah, you could try 4. I like it. If that's what you see immediately, then that'll be 4 times what? 20. So that what's the square root of 4?
2.
And what can I do with 20 though still?
4 times 5.
Alright, so is everybody cool with this so far? Do you see how I can't... It's not that... I'm not taking anything out of here. I am doing the square root of a part of it. The square root of 4 is 2. I didn't take a 2 out. So we just got to be careful about how we say this, because then people start just taking stuff out without doing any square roots, and then weird shit happens. I am taking square root of 80, breaking it into parts, and then doing a square root of one of those parts. That's completely legal. None of them's allowed to break out, tunnel under, right? The 4 can't go, I'm going to tunnel under here. Yeah, no. And so 20 I can do what with?
4 times 5.
Yeah, so it'll be square root of 20 is the square root of 4 times the square root of 5. What's the square root of 4?
2.
Times the 2 that's already there. So 4 square root of 5. Whoop. Right? It's the strangest sound effect. Now you could have, this is not the easiest thing to see, but 80 is actually 16 times 5. Square root of 16 is 4. And the square root of 5 is square root of 5. Bam! You see? So you kind of try to go with the largest square number that can go in, because then you're done. And of course, number 5, what happens with number 5?
Nothing.
Good. You circle. You say, I'm done. Next. Let's try a couple cube roots, and then we'll do a little bit out of the next section. Then we'll, like I said earlier, call it a day. What about the cube root of 64?
4 and 16.
4.
I like it. So this is 4 times 16. 16 is...
4 times 4.
So 64 is 4 times 4 times 4. So what's the cube root of 64?
4.
4. Because it takes 3/4 to make 64. So that was one that went evenly. So cubes, you should know your cubes. 1 cubed is 1. 2 cubed is 8. So we can do the cube root of 8. It's 2. 3 cubed is 27. I can do the cube root of 27. It's 3. So forth. So 4 cubed is 64. If I know that, that's an easy problem. It's a perfect cube, so I can take the cube root easy. This one not so good. But what of that list? 1, 8, 27, 64. Do you see that list? That's all the cubes. That's all the numbers that I want to try to work. Which one of those goes into 40?
8.
8. So I can break this up as cube root of 8 times the cube root of 5, because that's 40 there, right? What is the cube root of 8?
4. I mean 2.
Why is it 2?
If 2 takes 3, it takes 2.
Good. It takes 3 2s to multiply to be 8. What's the cube root of 5? I don't know, shit. So I'll leave it. Cool. One more here. How do you try to break that up? What number goes into 54 that's a cube?
9.
9's not a cube though, right? It's a square. Maybe go one more level of 3 up. 27. 27 times 2. So it's a cube root of 27 times a cube root of 2. That makes the cube root of 54. So I haven't changed anything, right? That still is the same thing. But what's the cube root of 27?
3.
3. What's the cube root of 2? I don't know. Third base. Coolness. Alright. So that's enough of that. Let's do a little bit. Just a few things real quick, and then I'll let you guys out.
Are we getting into division?
Yeah. Not immediately, after we do one thing here. So this is still section 12.3 real quick. So let's see, if I had the square root of 6 times the square root of 15, is either one of those something I can break down to something good? 6 is 3 and 2, 15 is 3 and 5. Nobody's got 2 of anything, but notice how they each have a 3. Very interesting. So what can I do?
Multiply?
Yeah, because they have the same root. So this would be the square root of 90. And now what obviously goes into 90? That's good.
45.
What makes it good in this case? The question is, what's the square root of 90? So I want to break 90 up into something I can actually do the square root of.
3.
I can do the square root of
3.
9. I can't do the square root of 3. But I can do the square root of 9 because 9 has 2 3's in it, right? Square root of 9 times square root of 10, because the square root of 9 is 3.
I was thinking ahead.
I think you were.
Yeah.
I wasn't sure.
Yeah.
Because you can't do the square root of 3.
No, yeah, no. I was thinking ahead. I was like, wait, 3.
How we do? So see how, like, neither one had 2 of anything, but they both gave each other a 3. Aw. And then the 3 could escape, right? And the 10 is still, inside. Hey. So what do you guys think about this here? I don't know, Jeff. There's 2 ways to do this. There's an easy way and a slightly harder way. No, you're thinking something else. We're not quite there yet. You definitely have to do that. But they have the same root, so what am I allowed to do? Yeah, I can make it one big ass root. What's 50 divided by 2? 25. What's the square root of 25? 5. So when they have the same root, I'm allowed to multiply them, and I'm allowed to divide them. Right? And again, don't forget why that's true, because they each have like a 1/2 power that I could take back out. That's how I proved it. Remember, this will be 50. How do I write this to a power? 50 to the 1/2 over 2 to the
1/2.
And that equals 50 over 2 to the 1/2. I could kind of take that 1/2 power out. And then I can do 50 divided by 2. That's why as long as they have the same root, I'm allowed to go ahead and do what it wants me to do, right? Multiplication or division. How are we doing so far?
So if it would have been 50 over the cube root of 2.
Then we would have been screwed like earlier.
Yeah, you would have.
Not only do they not have the same base, but they don't have the same power either. I mean, the same root. So what about, so on the heels of that question, what about this guy here? Radical notation is not useful with variables, basically. Radical notation is good for numbers, because I know what the square root of 4 is, but I'm not used to the 4 to the 1/2 power really yet. But radical notation sucks with variables. So what's a better notation to put it into? How can I rewrite cube root of x squared? What's on the bottom of plants?
2 over 3.
Yeah, the bottom of plants there are roots. So the roots are on the bottom, right? Just be my southern, I'm a Georgia boy, so it's really, really hidden. My accent is gone, basically. And so that's 2/3. Powerful on top. Roots on the bottom, plants on the bottom, right? X to the
1/4.
Yeah, understood 1/4. Roots on the bottom, power on the top. And then what do I do with those fractions?
Could like denominator
Why? What am I going to do with them?
divide.
No, I'm not going to divide
No,
them.
multiply.
I'm not going to multiply them. When I have like bases and I divide, I do what with powers?
Subtract.
Subtract. That was interesting. So 2/3 minus 1/4. That's the property I'm using. And then I got to go, oh shit, it's fractions, so I need LCD. So the property does not give the first shit about it. It says, you got to subtract them, whatever the hell they are. We're the humans, we go, oh man, we need LCD. LCD is 12. So it'll be x to the
8.
It needs a 4, so 8/12 minus
3 over
3/12, which we're finally catching up to the person that said 5/12. If I wanted to write that in radical form, what would it be? 12th root, x to the 5th. Roots on the bottom, power on the top. Coolness. Alright, so last thing. You ready? Last thing. This is section 12.4, by the way. Make sure I'm talking right. Yes. I want to preview one thing. This is the absolute last thing. Because the sooner I let myself out, too, the sooner my own spring break starts. So I understand how you feel. So I'm not going to hold this out long. So, of course, I'm going to make this a two-part problem. I just realized. Haha. Sorry. What do you think about this? Square root of 7 plus 2 square root of 7. What does your gut tell you about that? So I'm multiplying here.
No.
I don't know. All right, what is square root of 7? Do you know what it is?
No.
No, so I'm going to call it x, because I don't know what it is. And that's what I can do with algebra. So x plus 2x. What's x plus 2x?
3x.
3x. So root 7 plus 2 more root 7s is 3 root 7s. Kabam. So, part 2, if I had square root of 28 plus 2 square root of what, Jeff? Of, let's say, 63. Are those like terms? Are they like terms? Are they like terms?
No.
No, thank God. Square root of 28, I don't know what that is. This is like x plus 2y. Can you put those together?
No.
No. Why was this one easy? Because they were like terms. Thank you. They were both x. They were both the same thing. These are not the same thing. But what can I do?
Break them down.
Break them down.
7.
7 and 4. That's better.
So the 2 would come out. 7.
Right? And notice how they're both going to have the same thing left. So this will be 2 root 7. What's root 9? Times 2 is, so that's 6 root 7. So how many root 7s? 2 of these plus 6 of these is 8 of these. Don't let that be hard. Alright, that's it. That's fine.
Wait.
It's like a rubber band. You all were like, please.
You just added them at the end, or you multiplied?
You add them.
Okay, so
2 of these plus 6 of these is 8 of these. Right, that's it.
the 6 came out of
2 times root 9, because that's time. What is the square root of 9?
3.
3 times 2?
6. Oh, okay.
Because this what are each
Oh,
of
that
these
was,
things
the
doing?
2 was already outside. Right? Okay,
Yep.
got it.
Cool.
Did you get back test corrections or by chance?
Oh.
I was like a couple minutes late.
Gotcha. Yes, I got something here.
Yeah.
Still.
I
Yeah.
was like, why you got the 9? I was like, oh, that's it. Thank you.
Sure.
I was like, wait.